So yeah, they're up there, and all my notes and stuff if you're absent. Okay, so we solved the last problem by substitution, right? The warm-up problem. So I'm not going to go over that, and I showed you how to do that on the board. But an equation where it says solve by substitution, usually when you write a system is a two or more equations kind of grouped simultaneously, and we're going to find a solution to this system of equations. I would suggest this is a major part of this chapter, and I would strongly recommend that you put your books away and you write something down, okay? Take out a piece of paper, Katira, okay? We're taking notes now, all right? You're paying attention, you're focused, got it? Who knows how to do this? Claire knows how to do this. What do you do?
So you take the y and put in like the second equation.
Yep. So what do I plug into what?
So it's like 4x plus 2 times the quantity.
Very good. Perfect. So you take this, you take one equation. What you're trying to do with both of these, the elimination method and the substitution method, is get rid of one of your variables, because you could solve an equation that has one variable, but it's impossible to solve an equation that has two variables and come up with one solution, okay? So basically I just take 5x and I plug it in everywhere I see a y, and I get 4x plus 2 times 5x equals 7, and then what?
Then you distribute.
You have to distribute through, okay? And 4x plus 10x equals 7. 14x, should I do that right? Equals 7. Then what? Divide by 14. X equals 14 over 7 over 14, which is equal to what? 1/2, okay? So that's x equals 1/2. How do I find y? If I know x. Because a solution to a system involves finding both x and y. Jacob? Yeah, I would take it and you could plug it into either equation, but the easier equation, I think, is to plug it back in there. So you get y equals 5 times 1/2, and you could just leave that as 5/2, or 2.5, however you want to put it, okay, is okay. So where these two lines, if I were to graph these two lines, where they would intersect is at 1/2, comma, 5/2. Now, just to double check to make sure that that works, I'm going to take this answer and plug it into that equation to check, all right? So my check is going to look like 4 times 1/2 plus 2 times 5/2, and I want to see, does that equals 7, okay? What's 4 times 1/2? 2. What's 2 times 5/2? What could I do with this 2 and that 2? Do you guys know that I could cross this out and cross that out? Okay? So I get plus 5. Does that equal 7? Is that equal to 7? Is 2 plus 5 equal to 7? Yes. So my solution works. So you should always check by plugging your solution into the one that you didn't use, well, into either equation to make sure it works, but really you should plug it into both equations. Okay? Sophia? Will?
Yeah.
Put your head up and pay attention. Okay. So let's do another one. What if I said solve by substitution? Here's another system of equations. 12y minus x equals, oh, the big number, 68. And I have x equals 8y minus 12. Who can tell me what to sub into what? Jessica?
When you substitute 8y minus 12 for x.
Yep. So you could sub in for x or y. In this case, it's x equals this, so it's easier to take x here, right, and plug it in there for x. And this is where I guarantee half of you are going to make the same mistake over and over and over again. Because I saw this something very similar to this on your last test. 12y minus, you have to put this in parentheses, okay? So it's minus 8y minus 12 equals 68. Everyone see what I just did? Good. I substituted that in there. And the mistake that people always make, they forget to distribute this negative sign through. So when I distribute that negative sign through, I get 12y minus 8y. What does this 12 become? Plus, because it's minus minus, right? So it becomes plus 12 equals 68. Then I'm going to group my like terms, okay? So I have 12y and 8y. I'm going to put those together. 4y plus 12 equals 68. Then I'm going to subtract 12 from both sides. Minus 12 minus 12. 4y equals, what's that? 56. And then divide by 4, and I believe I get y equals 14. Okay? But I'm still not done yet, because I have to take my 14 and I have to plug it back in. Which is the easier equation to plug back in to get x? The top one or the bottom one? The bottom one's easier because it's already set up, x equals, right? So you're going to plug into that equation. When I plug in there, I get x equals 8 times 14 minus 12, which gives you x equals, I don't know what 8 times 14 is, 2856, I think it's 112. Is it?
Yeah.
112 minus 12, and you get x equals 100. So these 2 points cross at 100, comma 14. Yes? Now I'm going to check. So I'm going to take this answer and plug it into the top equation, because I already used this equation to solve for x. So I'm going to plug this setup, this point, and plug it back in here to make sure it works. So I'm going to go 12 times 14, because that's y, minus 100, and I want to see if that is equal to 68. 12 times 14, oh, that's big, isn't it? What's 12 times 14? Oh, it's 168. 168 minus 100, does that equal 68? Yes, it does. So it works, so I'm done, and that's my solution. Questions? So that's the check. All this time at those restaurants, I would ask for the check, and so someone would come up with some algebra equations and they would plug in some numbers for me. Okay, I'm just kidding. Okay, done? Okay, so you're going to try one. You ready to try? You try. Your turn. Oh, your turn. Your turn. So try this one. You could work with the person next to you. 5x minus 3y equals negative 1, and x plus y equals 3. Now, what I'm going to do for you first, see how these are not, it's not set up so that you can plug something into something else. So what you have to do first is get one of the equations like y equals, so you can substitute, right? So what could I do to this equation to solve for y? I want to get subtract x. So I'm going to subtract x from both sides, okay? And now I have y equals 3 minus x. And now I'm going to take that and plug it into here. Okay? So your turn, see if you could solve that by plugging in 3 minus x in for y into that top equation. Okay? Ready, go. Ready, go. I'm going to pause here. Recording anymore. There I am. So I get x equals 1. I take my 1 and I plug it back into the easier of the two equations, which is this one. And you could just do it by inspection, right? 1 plus what number equals 3? What does y have to be? 2, right? See where? And then you should take it and plug it back in here to make sure it works. 5 times 1 minus 3 times 2. Does that equal negative 1? And it does equal negative 1, so it checks out. Okay? Questions about the substitution method? You can do that? You ready for the elimination method? Have you done the elimination method before? Okay, so elimination method is kind of a good way to solve equations too. And depending what the equations look like, use either the substitution method or the elimination method. So with the elimination method, whoops, I lost my notes. Where's my notes? Notes. You're set up with equations that kind of look like solved by substitution. 2x plus, minus 3y equals 14, and 4x plus 3y equals 46. That's a 14. Can you tell that's a 14, or does that look like an H? I know it's like an H. Let's make that into 14. Okay, so if they say solve the system, solve by elimination. So elimination means eliminate one of the variables. And what elimination uses, it uses the idea that if two things are equal on either sides of an equation, I can add equal things to the other side, to another equation, and that equation will still be balanced, right? If I have an equation, here's my equation scale, and I have this thing equals this thing, right? If I pile on 2 more things, right, or 3 more things that are equal, will that scale still stay in balance? Yes, okay? So what you do with elimination, you add equations together to make something disappear, okay? Since these two things are like little balanced equations, they tell me they are, then I should be able to add them together and they will still be in balance. So notice what happens when I add these two equations together. Add my x's together, what do you get? 6x. Add my y's together, what do you get? 0 equals, add my constants, those are called the constant terms over here. I get 60, and then I divide by 6, and I get x equals 10, and then you should take 10 and plug it in to find out what y is. So I'm going to take 10, plug it in here, and I get 2 times 10 minus 3y equals 14. 20 minus 3y equals 14. Subtract 20 from both sides. Subtract 20. I get negative 3y equals negative 6. Divide by negative 3. Am I going too fast? I get y equals 2. Okay? So where these two equations cross, if I were to graph them, would be at 10, comma 2. Okay? I'm going to check it. You really should check it every time by plugging those numbers into this equation, because I already used the top equation. I want to see, does 4 times 10 plus 3 times 2, does that equal to 46? Well, that's 40, that's 6. Does it equal to 46? Yes, so it checked. All right? So that's called the elimination method. Now, unfortunately, sometimes you have to change equations to make the elimination method work. Okay, you ready for another one? All right, we got 2 more examples, and then we'll be done. Okay. So if you see something like this, new example. If you see something like this, 6x plus 4y equals 2, and 8x plus 2y equals -1, and they say solve by elimination. Does anyone know how to do this type of problem, Kaylee?
Would you find like a common factor for like 4 and 2?
Yeah, so what you want to do, you want to change this number into something, either the y's or the x's into a number, so that when they add them, one of them disappears. Okay? So what do I want this? I could change this 6. It's harder to change a 6 into an 8. How can I change a 2 into a 4? Multiply by -2. But when I do that, I have to multiply the entire equation by -2. So I'm going to times this by -2.
Why by -2?
Because then when I add them together, because I like adding better than subtracting. And when I add them together, things are going to disappear. So multiply by times -2. So when I do that over here, -2 times 8x, which I can do, as long as I'm doing the same thing to every term in the equation. Okay, -2 times plus 4 makes what? I mean, -2 times +2 makes -4y. And don't forget, you also have to multiply this. So what's -2 times -1? 2. Then I'm going to bring this equation straight across. Okay? 6x plus 4y equals 2. And then I can add them together. What's 6x plus -16x? -10x. And what I set out to do was eliminate those. And I get 4. Do I get 4? Did I mess up? I don't think I messed up. Oh, I get some ugly looking answer. So I'm going to divide by -10. Should have made it come out nicer. -10, -10. That goes away. I get x equals 4 over -10 is the same as -4 over +10, which reduces to -2/5. Okay? I'm not done because I have to take that and figure out what y is. Okay? So I'm going to take, now you got to worry about fractions. Okay? So I'm going to take this and plug it in here. And hopefully it won't work out too bad. So I'm going to get 6 times, change of color, to -2/5 plus 4y equals 2. Okay? Then I multiply across. What's 6 times 2/5? -12/5 plus 4y equals 2. It doesn't always come out nice and neat. Now what? How do I get, not subtract 12/5, add 12/5 to both sides, right? Plus 12/5 plus 12/5 and plus 12/5. I don't know. This goes away. I get 4y. I'm going to change 2 into fifths. How many fifths is 2? 10/5, right? I'm going to add together 10/5 and 12/5. That gives me 22/5. Oh my God. And I got to divide that by 4. couldn't we have picked a cleaner example? Divide by 4. Hopefully you won't have any this horrible. So now I gotta divide 22/5 by 4. So I get y equals, do you know about copy dot flip? 22/5 times the reciprocal of 4, which is 1/4. And I get y equals 22 over 20. And 22 over 20 is 11 over 10. And I'm done, okay? So negative 2/5 for x and 11 over 10 for y. Sometimes they'll come out as, I got it right. Sometimes they'll come out as fractions and you just kind of have to deal with it, okay? Sorry. Did I go too fast? Do you like fractions? You have calculators, most of you, that do fractions. So you could use that. Like, I'm not testing you right now on whether you can do fractions or not. Can I do one more example? Because you're going to see one more type of problem. Okay? The last type of problem that you're going to see is where you have to do something to both equations to do elimination. So, and this one comes out nice and neat, actually. 2x minus 5y equals 1. And 3x plus 2y equals 11. And they say solve by elimination. Anyone know how to do a problem like this? You want one of the variables to cancel out, either the x's or the y's. What will both 2 and 3 go into? 6. So I'm going to turn it, I could either turn these into 10s or this into 6. What could I multiply this top equation by to turn the x's into 6? 3. So I'm going to multiply the top equation by 3. I wanted blue ink. I'm going to multiply the top equation by 3. What should I multiply the bottom equation by? Negative 2. Because I want one to be positive and one to be negative. When I do that, this one becomes 6x minus 15y equals 3. Okay? And this one becomes, this is confusing because it looks like x, it means times, right? 3 times, 3 times. So I'm going to multiply negative 2 times this, which gives me negative 6x minus 4y equals minus 22. And then I'm going to add those two equations together. This goes away, right? I get, what's negative 15 and negative 4? Negative 19y. What's 3 plus negative 22? Negative 19. What's negative 19 divided by negative 19? 1. Finally one that works out nice and neat. Okay, negative 19. And that means that y equals 1. And then I'm going to take that and plug it back in. I just plug it back into one of the original equations. So, whoops, I'm not going to plug in there, am I? I got y, so I'm going to plug in here. So I'm going to get 2x minus 5 times 1 equals 1. I'm trying to solve for x now. So 2x minus 6 equals 1. What? Minus 5, I'm sorry. Minus 5. Minus 5 equals 1. That gives me 2x equals 6. X equals 3. Okay? So I have to have an x and a y. So my solution to this equation, you want to write it as an ordered pair. 3, 1. I would take that answer and plug it in to make sure it works. 3 times 3 plus 2 times 1, does that equal 11? Is that equal to 11? Yes, so that checks. So that's my solution, 3, 1. Tricky. I know I went fast, but you guys only have 5 homework problems out of your book and 5 problems on Math Excel. So it's not that bad. Last thing, I just want to talk about one more very last thing, okay? If you solve a system of equations, and you end up with something like 3 equals 3, do you know what that means?
One.
It means there's infinite solutions. Okay, if you end up with something like that, infinite solutions means it's the same line. Okay, same line. If you end up with something like 0 equals 2 or something like that, what does that mean? There's no solution, and that means they're parallel lines. Okay, parallel. All right. So just so you know, if you're doing elimination and you end up with this side equals that side, or this is equal to that, that means there's no solution because there's no place that 0 is equal to 2. Okay. So your homework, I'm done. Your homework's on Schoology. Okay. And sorry I had to talk at you so much, but that's the way. Great.